Okay, so when we're talking about quadratics, when we were talking about graphing them, we were finding whether we had one, two, or no x-intercepts. And so the way we did that was first we used our formula negative b over 2a, which some of you might recognize as the start of the quadratic formula. So we took the negative b, which in this case would be negative 6, over 2 times our a, and our a value is 1. By doing that, we can find the x value of our vertex. So in this case, we have negative 6 over 2, which gets us a negative 3. So again, that's our x value of the vertex. We then take that value, plug it in for our x values. So we have negative 3 squared plus 6 times negative 3 plus 5 equals not 0, but y. Right? It's going to find us our y value of that vertex. Negative 3 squared gets us 9. 6 times negative 3 gets us a negative 18. Plus 5 equals y. So 9 minus 18 gets us a negative 9. Plus 5 gets us a negative 4 for the y value. So that means our vertex is at negative 3, negative 4. And so they give us that graph on the paper. And so with the point negative 3, negative 4, that is our vertex. So negative 3 on the x, negative 4 on the y. And then we determine how many solutions we have based on our a value. Again, our a value, if it's positive, we open up. If it's negative, we open down. In this case, we have positive x squared, so our a value is positive, meaning we're going to open up. And that means we're going to have two solutions for whenever we solve using one of these other methods. Okay. So one of those methods that we're going to look at is factoring. So again, using the same problem, x squared plus 6x plus 5. Equals 0. And we want to factor this. So anytime we have that trinomial, again, two sets of parentheses, equals 0. What are my signs going to be when I factor this? How do we determine those? Plus, plus, right? We look at our c value. If it's positive, we use the same sign as our b value. It's positive, so we're going to use a plus and a plus. So we need two numbers that multiply to get 5 and add together to get 6. 5 and 1. And then we want to solve, so we're going to take both of these factors, set them equal to 0. So x plus 5 equals 0. X plus 1 equals 0, and solve for those x values. So subtract 5, we get x equals negative 5. Subtract 1, and we get x equals also negative 1. Put them in the little curly brackets as our set. So when I graphed that, I actually came very close to hitting that. It was off a little bit on the negative 5. But those are our solutions where we cross the x-axis, negative 5, negative 1. Okay? So that's one way we can do it. Another way we can solve quadratics is by taking square roots. We have x squared plus 6x plus 5 equals 0. One of the ways we can solve quadratics is by taking square roots. However, because we have this 6x term, we have a b term that is not 0, we cannot actually solve it by taking the square root. So in this case, it's not possible. But let's say we had an equation that was like 4x squared minus 49 equals 0, where we don't have that b term, right? We can solve this one by taking the square root. And the way we would do that would be add 49 over we get 4x squared equals 49. Divide them both by 4, so before we can take that square root, do your division. That gets us x squared is equal to 49 divided by 4. And the last thing is we want to get rid of that square root, so we take the square root of both, or get rid of the squared, so we take the square root of both. So that's going to get us x equals, again, anytime we take that square root with an equal sign, we always want to have a positive and negative answer. Square root of 49 would get me 7, and square root of 4 would get me a 2. So there's two answers, again, a positive 7/2 and a negative 7/2. Okay. And then our last method of solving would be our quadratic formula. And again, the quadratic formula works for any case of quadratics. So we can always use it, but it's not always the quickest or the easiest to use. So again, our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So we're taking our a term, our b term, and our c term, and we're plugging them right on into our quadratic formula, which again solves for that x-intercept, or those zeros. So let's take negative b, which could be negative 6, plus or minus the square root of b squared, so 6 squared, minus 4 times a. Our a value again is 1, times c. Our c value is 5. All of that divided by 2 times our a value, which again is 1. And then we want to simplify that down as much as we can. So in this case, we have negative 6 plus or minus the square root of 6 squared would be 36. Then we have a negative 4 times a 1, which is still negative 4 times 5, negative 20, all over 2 times 1, or 2. We can reduce that inside of the radical. 36 minus 20 will leave us with 16. Divided by 2. We can take the square root of 16. That is going to get us 4 divided by 2. So again, here's where we get our two answers, right? We have a positive and a negative. So we have a negative 6 plus 4, which gets us negative 2 divided by 2, which would be negative 1. We also have negative 6 minus 4, which gets us negative 10 divided by 2, which is also negative 5, which is what we got from our factory, right? Same problem, same answers, different method. Except this takes a lot longer than our factoring does. Okay, so that's why if we can, we want to do factoring. This is kind of our last resort. It'll always work, but it just takes a little bit more time. And it's a little bit more complicated, meaning we might make a mistake. We wouldn't if we did something easier. Okay. Any questions on those methods? So that kind of takes you to the homework. So the homework is this review. And so what we're going to do, you've got 20 problems. All of the methods that we just talked about are up here. Okay, so you've got greatest common factor, your normal trinomial factoring method. You've got your quadratic formula. And we've also got one, which is solving by taking the square roots. Okay? So let's do an example. Let's do the first one. We have 2x squared plus 8x equals 0. What method would be the most efficient to use? Greatest common factor. So this one's GCF. What is the greatest common factor between these two? 2x, right? They both are divisible by 2, and they're both divisible by x. What do we have left when we factor out that 2x? X plus 1. Again, once we've done that, we set both of these equal to 0 and solve. We want to get x by itself, divide by 2. We get x equals 0, subtract our 4. We get x also equals -4. So there's our solutions. And so what we would do then is we want to look at the bottom of the page. We want to find 0 and -4 as our possible solutions. So if I'm going through, there it is. We have -4 and 0, and that's our letter M. So what I'm going to do then is I'm going to take that M and I'm going to put it at the bottom of the page along here. Now, if you solve these all correctly, it will make a phrase and it will make sense. If we've messed up, it'll be spelled incorrectly or not make any sense at all. Again, you're only going to use one of these answers once. So once you've done it, we've used our M here, we can mark this one out. We won't use it again. Any questions on that? Let me give you guys a little bit of a hint. When you're trying to decide what method to use, if we have the form of x squared plus bx plus c equals 0, you can either factor that, if it's possible to factor, or you're going to have to use the quadratic formula. If we have ax squared plus bx equals 0, it's a sign you want to use GCF. That's what we just did. If we have something that's x squared plus c equals 0, that one we can solve by taking the square root. Okay? So there's kind of your 3 or 4 methods, right? You can factor if it's a trinomial, and if the factoring doesn't work, you're going to have to use quadratic formula. If we have an x squared and an x value, we can use GCF. If we have an x squared and a constant, we can use the square root method. You want to use these before you go back and use the quadratic formula. Again, you can use quadratic formula for anything that's quadratic related, but it's not always the easiest way of doing it.